Hello best engineers, welcome to the new video. In this video series we are going to strength of material questions based on interview preparation and competitive exam preparation. Let us move into the topic. Question 1. For a simply supported beam, subjected to a uniformly distributed load UDL over the entire span, the maximum bending moment occurs at the center. If the span length is L and the UDL is W, what is the maximum bending moment? These are the answers. For a simply supported beam with a uniformly distributed load W, the maximum bending moment occurs at the midpoint. The formula for the maximum bending moment is WL squared divided by 8. Next, let us see the different types of beams, maximum bending moment, slope, and deflection. First, cantilever beam subjected to a moment at end. Its maximum bending moment is m. The slope is theta is equal to ml divided by EI. Now substitute the m. The slope is ml divided by EI, and the deflection delta is equal to theta into L by 2. Substitute the theta value. The deflection is ml squared divided by TI. Similarly, this is the formula for cantilever beam carries a point load W at the end. This is the formula for cantilever beam carries a uniformly distributed load W over the span. This is the formula for cantilever beam carries a uniformly varying load W over the span. This is the formula for simply supported beam carries a point load W at the mid of the span. This is the formula for simply supported beam carries a uniformly distributed load W over the span. Question 2. A solid circular shaft is subjected to a twisting moment T. The shear stress at any point on the shaft at a radius r is directly proportional to. These are the choices. Now the shear stress equation is T by J is equal to τ by r, also equal to G theta by L. From this we can note that the torque is constant but the stress will vary linearly with the radius of the shaft and inversely proportional to the polar moment of inertia. The correct answer. The shear stress tau in a solid circular shaft under a torque T varies linearly with the radius r from the center. Question 3. A steel rod of length L and cross-sectional area is subjected to an axial tensile force P. The Young's modulus of steel is E. What is the elongation delta L of the rod? These are the options. The Young's modulus is the ratio between the stress and strain. Stress is the ratio between load and area. Strain is the ratio between change in length to original length. Now alter the equation. The option A is the correct choice. Question 4. A rectangular beam of width and depth is subjected to a bending moment. The maximum bending stress occurs at the bending stress distribution in a rectangular beam subjected to bending moment M is linear across the depth. The maximum bending stress occurs at the extreme fibers, i.e. at the top and bottom fibers of the beam. The correct options are B and C. This is the explanation. The maximum bending stress in a rectangular beam subjected to a bending moment M occurs at the outermost fibers of the beam, which are located at the top and bottom surfaces of the beam section. This stress can be calculated using the flexural formula. This is the formula where sigma max is the maximum bending stress, M is the bending moment, C is the distance from the neutral axis to the outermost fiber for a rectangular cross-section, I is the moment of inertia of the beam cross-section. The moment of inertia for rectangular beam is C is the distance from neutral axis. Substitute this, we can know the distance where the bending moment will occur. Question 5. The slenderness ratio of a column is defined as the ratio of its effective length to. These are the options. Slenderness ratio is the ratio between effective length to radius of gyration. The slenderness ratio is a dimensionless quantity used in structural engineering to describe the propensity of a column to buckle under axial load. It is a critical factor in the design of columns, determining their stability and capacity to bear loads without failing due to buckling. The radius of gyration, r, is a measure that relates the distribution of the cross-sectional area to the axis about which it buckles. Thank you guys, let's mirror in another video. Thank you.